Example 6. So the number of people in thousands employed in a resort town can be modeled by g of x equals 1.5 times the sine of pi over 6 times x plus 2, all plus 5.2, where x is the month of the year. We want to graph the people employed in the town for one complete period. So first, our amplitude. Amplitude is always the number multiplied in front of the trig function, so that would be 1.5. So that means that horizontal line that divides the sine function in half, the distance from that line to the top and bottom of the graph is 1.5 units. Period utilizes the b value, which b is what's multiplied in front of x, which is pi over 6 in this case. So if we take 2 pi divided by pi over 6, that's going to equal 2 pi times 6 over pi, which is going to end up equaling 12, which is logical because there are 12 months in a year. And this is based in terms of x being the number of months in the year. Phase shift is how the graph is moving left or right, and that's coming from what's being added or subtracted with x. So here we have a plus 2, but remember x is always lie, so that means we're really going to go 2 months left. So that means normally the graph, one length of the period would be from 0 to 2 pi, or to 12, from 0 to 12, that's one length of the period, but now we're going to shift everything back 2 months. So really, if you're thinking about that parent function of the sine curve, it's going to look like that, but shifted backwards a little bit. Vertical shift, meaning how far up or down the graph is being moved, is this number added here, the 5.2. So everything is getting moved up 5.2. So normally with our parent sine graph, it has this horizontal line at the x-axis that divides the graph in half. Well, now all of these points that were on the x-axis are going to be up 5.2 units because now that's going to be the line that we're then going to add and subtract the amplitude from to find our maximums and minimums, which is the next part of this. So to find our maxima, we're going to take our vertical shift of 5.2 and add in the amplitude to give us a maximum of 6.7. The minimum is going to be that shift, that vertical shift, but then minus the amplitude, so minus 1.5, and that'll be at 3.7. Now, I want you to think about how this graph would look before some of these shifts up and down and forward and backwards, okay? So if we think about this, right, 12 months is out here, then that means 0 is here. So normally our graph, which all of these trig graphs can be divided into 4s, right? So if the period is 12 months, that means from 0 to 12 months, I should see one cycle of that sine wave, right? So that means the halfway point at 6 months, it would be like on the x-axis. And then the halfway point, so at 3 months, it would be at the maximum. And then at 9 months, it would be at the minima. And this is before any of those like shifts are happening of it moving backwards and moving up 5.2 units. So just a sine graph having a period of 12 months means it would look something like it does here in the bottom of this screen that I've drawn, where we see that full sine cycle, which starts at 0, 0 and ends on the x-axis between 0 and 12 months. But now we're taking that and we're shifting it back 2 months. So now it's like it's going to go from negative 2 months to 10 months, and all these points are being shifted back. And then we're going to take all these points and move them all up 5.2 units. That is what we're going to do on the next slide. So I've gone through and labeled some things already. We have our months down at the bottom, and then I have the y-axis going by ones. first thing I like to do is to kind of draw out these barriers, my maxima, my minima, and then where that horizontal center line is going to go, just to make sure that I'm not getting lost with all these different numbers and all of these different barriers. So I'm going to draw a dashed line at about 6.7 for the maxima, and then at about 3.7 for the minima. I'm also going to draw in a line in the middle, which would be like that horizontal line that would divide up the sine wave in half, and that is going to occur at 5.2. All right, now remember in this last slide, I had said 12, which is normally on the x-axis, is now getting pushed back 2 months and up 5.2 units. So what was normally at 12 is now going to be at 10 months, and the x-axis is no longer the center line, it's now that blue dashed line I have. So I know I'm going to have a point at 10 and then the 5.2. So that dot I have drawn in at 10, 5.2 is the transformation of this point right here, but moved back 2 months and up 5.2. Now the next one I'm going to move is the one that was originally at 6 months and on the x-axis. So I'm going to move that back to 4 months and then move it up to my new horizontal center line, which is at 5.2. So at 4 months, I'll be at 5.2. The next one I'm going to be looking at is at 0, 0. So that one, if I move it back 2 months, would be at -2, and it's just not logical with the concept of this problem, so I'm not going to graph it. So now I'm going to look at all these points that are at my highs and lows. So I originally had a maximum at 3 months, but now I'm going to move that back 2 months. So 3 minus 2 takes us to month 1. So I'm going to have a maximum at that 1 month mark. So it was at 3 months, but it's been shifted 2 months back because of that phase shift. Then I had a minimum at 9 months, but I'm going to move that 2 months back. So now at 7 months, I'm going to have a minimum. And so this is where I am left with something that looks like this. Doesn't look like a whole lot of anything, but with what we have, this would be a picture of the graph. All right, now it says what is the maximum number of months that, or the maximum number of people employed. So 6.7 is that maxima barrier. So it's in terms of thousands. So if we take 6.7 and multiply it by 1,000, we would get 6,700 people. All right, that wraps up example 6 and the 11.1 notes. Now you can move on to the homework assignment. Thank you so much and have a great day.